So today we're looking at differential equations. What is that? You know how you have like linear equations, you have like quadratic equations, you have like exponential equations. Well, this is just another type of equation. It's a differential equation. What does that mean? It means, what is it? Okay, let's write that down. What is a differential equation? It's a very simple definition. It's just an equation involving derivatives of a function or function. So when you take the derivative of something, that's actually a differential equation just by the definition. But we have so let's compare it to like quadratic equations. If you had, let's do this in green. If you had something ax squared plus, well, let's see this, f of x equals ax squared plus bx plus c. If you just had a quadratic equation, the solutions of these are just numbers. They're, well, I mean, I guess they could be imaginary or real numbers, but they're just numbers. Solutions are números, are numbers. Numbers. The difference with differential equations, if you have a differential equation, they have a bunch of different forms, but differential equations, maybe I shouldn't have done this in this color, but I already committed. So differential equations, the solutions are functions. And functions are functions. What does that mean? Well, I'll show you. So that's the difference here. When you solve a differential equation, you end up with a function. So let's see what the heck I'm talking about. Let's write an example of a differential equation, and then I'll show you what the answer looks like, the solution to it looks like. There's a bunch of different solutions, most of the time, and then yeah, we'll verify that it's a solution. So because that's what we're doing. So let's take a look. Here's a differential equation, and there we have it. Y double prime, meaning the second derivative of whatever y is, plus 2y prime equals 3y. That is a differential equation because it involves derivatives. It can involve regular functions as well. Y in this case could be a function of x, could be a function of t, could be a function of anything, but in this case it's a function of x, and we're gonna see something about that. We're gonna verify that it's a solution. So this is not actually an example. I mean, it's an example of a differential equation, but we don't have any instructions of what to do with it. So I'll write those right now. So for this set of problems that we're gonna be doing, we're just verifying solutions to differential equation. We're not finding them yet, but we're just verifying. So here we go. We have the differential equation right there, and it says verify that y equals e to the negative 3x is a solution to the differential equation above. Okay, so we have to verify. What does that mean? Well, if you had, say, like a quadratic equation, to verify, like x equals negative 2 and x equals 1. To verify that these are solutions of a quadratic, you'd simply plug in the 1 for x. You'd also plug in the negative 2 for x. And if you get a true statement, you'd be good. You would, or if it equals 0, right? Because you'd set it equal to 0 to find the roots. So if you plugged in 0 for this, and then plugged in your x values, and you got a true statement, then yes, it would be a solution to the quadratic equation. Well, it's almost the same way. You're going to do what it says, so take the second derivative of this, plug it in. You're going to also take the first derivative of this, times it by 2, and then add those two things together. And you're going to see, does it equal 3 times this? And if you get a true statement, then you have verified that it's a solution. So all we're going to do to verify a solution, all we're going to do is what it says to do. So that means I need the second derivative, y double prime. I don't know what it is yet. and I need the first derivative, y prime. I don't know what it is yet. I mean, I do, but and then I also need the regular function. So I need y, and I know what that is already because they give it to me. Okay, so let's verify. The first derivative, y prime, the derivative of, this will be using chain rule. The derivative of e to the negative 3x is just e to the negative 3x. That's the derivative of the outside with the inside the same, times the derivative of the inside, times negative 3. So that's the same thing, y prime. That's the same thing as negative 3 e to the negative 3x. So there we go. We got the first part. So that's done. I still need the second derivative, so I'll just keep going. Y double prime. You leave the coefficient out front, of course. The derivative of e to the negative 3x is the same thing. You got to use chain rule. So it would be negative 3 out front. E to the negative 3x. The derivative of e to the x is e to the x. So I take the derivative of the outside with the inside the same, times the derivative of the inside. So I get that. Y double prime equals positive 9 times e to the negative 3x. So I'm ready now to plug stuff in. So I found the second derivative and the first derivative, and now I'm plugging stuff in. That's all I'm doing. If I get a true statement, that's it. I'm done. I can go to sleep. I can just go to bed. I don't know why that's what came into my brain, but here we go. So I take the second derivative of the function. I'll do it in green. Second derivative, which is 9 times e to the negative 3x. 9 times e to the negative 3x. That comes first. I add it plus 2 times the first derivative. What is the first derivative? Well, it's that. Negative 3, maybe I'll, there. Negative 3e to the negative 3x. Okay. And then it's saying that must be equal, for it to be a solution, it must be equal to 3 times the original function. So we have this. I need the 3, right? 3 times e to the negative 3x. Now I'm just going to simplify the left side and see if it equals that. If it does, then I have verified that it's a solution. So I have 9 times e to the negative 3x. It looks like minus 6 e to the negative 3x equals 3 e to the negative 3x. I'll combine like terms, right? It's just the same as if I had 9x plus, or minus 6x. Minus 6x. I can combine like terms because those are like terms. Same thing here. So I have 9 e to the negative 3x's, and I want to take away 6 e to the negative 3x's. So 9 minus 6, that's 3. I'll do it in green. 3 e to the negative 3x, which is what I wanted. So yes, we have verified that that's a solution. That's all we're doing today, just to get comfortable with the idea that the solutions to these equations are actually functions. The solution is a regular function, it's just not derivatives, it's just a regular function. Later on we'll figure out how to find, there's a bunch of different types of differential equations, and we're only going to learn the basics. But there we go. That's all you got to do. That's it. We're going to be done now.